number 11. Horizontal asymptotes. So I'll blow that up a bit. Okay. So here's a question. For a function, how many horizontal asymptotes can you have at most?
2.
2. Why?
Limit as x approaches negative and positive infinity.
Right, there's only 2 sides of it, right? So you have the negative infinity side and the positive infinity side. And you can probably rig it such that they can be different, right? Because if you remember that rational function we had on Wednesday, they were different. Yeah. So you can have at most 2 because there's only the positive infinity and then the negative infinity. Okay? So here you have at most 2. And that's why you see sometimes with 2 answers here, and that's one of the critical things to remember here. Remember to check the negative infinity for an asymptote as well. Because most people just start with the positive infinity. All of 15. Okay, so we have f of x is equal to e to the x plus 2e to the negative x over, so this is a very common one, I think, e to the x plus 3e to the negative x. Alright, so we have the 2 asymptotes. So we have the plus infinity one. So this one is, we need to compute the limit as x goes to infinity of e to the x plus 2e minus x over e to the x plus 2e minus x. Alright, so how do you do that? The answer is not L'Hopital's.
Oh, you divide by e to the x, right?
Yeah, you divide the top and bottom by e to the x. Okay?
Same group.
Yeah, so e to the x, 1 over e to the x. Does everyone understand why this is the approach, not L'Hopital's?
Same degree, right?
Yeah, so the same degree is the degree of e to the x. So this is equal to limit x goes to infinity of 1 plus e minus 2x over 1 plus, 3 e to the negative 2x. So that's equal to what?
1.
1. Why?
Because that goes to 0, so you 0.
Yeah, e to the negative 2x goes to 0, right? So that equals 1. So this one gives you the horizontal asymptote. Y is equal to 1 at positive infinity. Does that make sense? Now we do the same thing for the negative infinity side. So you have the limit as x goes to negative infinity of e to the x plus 2e to the negative x over e to the x plus 3e to the negative x. Now what do you have to do?
Divide by e to the negative x?
Yeah, divide by e to the negative x, because as x goes to negative infinity, this goes to infinity now. The issue flipped. Okay, so just doing this algebra quickly, so you have the limit. X goes to negative infinity. So if we divide by this turns into e to the 2x plus 2 divided by e to the 2x plus 3. So what is that?
2 over 3.
2 over 3, because now as x goes to negative infinity, e to the 2x goes to 0. So now you get 2/3, and then you have your second horizontal asymptote as y is equal to 2/3. Yes?
How do you know you have to divide by e to the negative x instead of e to the x?
So the issue is like, for instance, if these are like just x's and 1 over x, right? This one goes to 0 here for the positive one, while this one goes to infinity. So you're going to kill off that infinity in the denominator. So as he said, you divide by the highest ordered terms. Like if this was at an x squared, you divide the top and bottom by an x squared. So this is not polynomial, but e to the x is clearly the driving force here. So you divide out the top and bottom by e to the x. Does that make sense?
Yeah.
Okay. Likewise down here, if the issue flips, e to the x goes to 0, while e to the negative x goes to infinity as x goes to negative infinity. So that's the one you have to kill off. Right. I just want to point out here, be very careful. Does L'Hopital's work?
No, 0, 0.
I mean, you can rig it up to be 0 to 0. Because for instance, this would be infinity plus 0 over infinity plus 0. Alright, so that's still L'Hopital's. Why can't you apply L'Hopital's, or why would that be too useful?
You'll just keep giving e to the x.
Right, there's this e to the x's all over the place. The derivative would be e to the x minus 2 e to the negative x, and then this thing will just keep happening. So L'Hopital's is not a great option here, which is why you need to do it this way. Okay? So just keep that in mind. If you see things like cycling like that, so sines and cosines and exponentials are good ones that L'Hopital's like kind of struggles with. Alright, just keep that in mind. Alright. Did this make sense? Any comments? Origin is 2 asymptotes, and negative infinity is the other one. Okay. Fall of 17, number 9. So this one is, I would put it as mildly annoying. Does everyone agree? Yeah. So I would classify these by annoyance, if anything. So why am I saying this is mildly annoying? Like, what do you have to do?
This is all 17.
Yeah, so you have to compute the, yeah, so you need to compute h prime of 0. Oh, that's 0. So you need to first compute h prime of x, right? And how would you do it with this? So in general, is a function or a function, right? So how would you compute? Yeah, that's why I said this is mildly annoying. So it'd be the quotient rule, and then if you squint hard enough, what else do you see in there?
Chain rule.
Chain rule. That's why I said this is mildly annoying. So we have h of x is equal to f of 2 on top e to 2x divided by g of e to the 3x. Alright? So what's the quotient rule here?
Derivative top times bottom minus derivative bottom.
Yep, so the derivative top is,
Yeah.
yep, and then what?
2 e to the 2x.
2 e to the 2x, that's 2x, then you have g of e to the 3x, minus what?
Derivative e to the 3
Yeah, so you get the g prime of e to the 3x, 3e to the 3x, f of e to the 2x, right? And then divided by the denominator squared, g of e to the 3x. Okay? So that's why I said it was mildly annoying. You gotta keep track of all those chain rules. Oh, this is in fact good. Right? You gotta keep track of all the chain rules, all the quotient rules, and all of that. Okay. At this point, I wouldn't simplify. I would just evaluate h prime of 0 is equal to f prime of, so you have e to the 2x, so that turns into what? 1. Times 2 times e to the 0 is another 1. G of 1. Right? And these are all values that they give you up there. So it's just like piecing this together correctly. And then you have minus g prime of 1 times 3 times 1 times f of 1 divided by g of 1 squared. All right? Everyone okay with me just stopping there with that? And now it's just like you have f of 1 is 2, f prime of 1 is 9. You just plug in those numbers and you'll get one of those. So that's why I said